This is a really important problem. You will see these problems show up very frequently in FRQs. In fact, you've probably already seen one at this point. So let's go over how to solve these. Okay, so when is f at a maximum? So I've got this expression here. So when is f at a maximum? And notice that this is lowercase f of t. This is not uppercase f. So f has a maximum. I'm just going to write this out because I know this. F has a maximum when f prime of x changes from, so when the slope of f changes from positive to negative. So I'm actually just going to write that out now because I know that's true, but I don't know what f prime is yet. So f has a max when f prime changes from positive to negative. Okay, so how do I figure out the relationship between f and f prime? So I'm given f of x is equal to this integral. So if I take the derivative of both sides, derivative of capital F is capital F prime. And then the derivative of your integral using FTC. So remember, derivative of the bound times the bound plugged in. So that would be 1 times f of x minus 0 times f of 0. So capital F prime of x is equal to f of x, lowercase f of x. So you got to pay attention. This is really confusing. On the AP exam, they don't use a bunch of f's. They'll use an f and a g. But instead of using f prime, I can replace that with lowercase f of x changing lowercase f of x. When is lowercase f of x changing from positive to negative? And it's not the slope I'm looking at for f of x. So I'm not looking at the slope. I'm looking at when do the values change from positive to negative. And what I notice is that that doesn't happen. So I don't have a local maximum. So this does not happen. So that means there is no local max. Well, if there's no local max, then how can there be a maximum? Okay, well, we also do have endpoints, right? My graph is ending. So let's figure out what's happening on capital F. So what I'm looking at is the derivative of capital F. So what this tells me is that the slope of F, capital F, is positive. Then at 4, it's 0. And then this is a horrible graph, but it's okay. I'm just sketching it. Then my slope is positive. And then my slope continues to be positive until at 15, it's a slope of 0 again. So when is it at a maximum? At an end point. So remember, critical points and end points are also candidates for maxes and mins. So in this case, F has a, should be a capital F. Capital F has an end point max at x equals 15 because capital F prime of x is greater than or equal to 0 at all points on the closed interval. So this is how I'm explaining why it's an endpoint maximum. And that's because if your slope is positive or 0, that means your function is increasing. If your function is increasing, it has an endpoint maximum if there's an endpoint. In this case, there is an endpoint. So I can call that an endpoint maximum. All right, for part B, is f increasing, decreasing, or both on the interval from 0 to 8? So from 0 to 8, which is here, you'll notice that capital F prime is equal to f of x. So remember, f of x is the graph we're looking at. This is the derivative. This is the slope of f, capital F, is positive. Actually, I'm going to say is greater than or equal to 0 for all points on 0 to 8. And capital F is increasing. Actually, I should say like so f is increasing. Okay. Part C, evaluate capital F of 4, f of 10, and f of 15. So f of 4 is equal to the integral from 0 to 4 of f of t dt. So now I'm kind of going back to the original part because this is like where I'm given an actual function. Capital F of 4, plug in x is equal to 4. So the integral from 0 to 4 of f of t dt, well, that is a quarter circle because it does say circular. So that's going to be 1/4 pi r squared, which is 4 pi. Okay. Capital F of 10 is the integral from 0 to 10 of f of t dt. Again, going back to that original problem and plugging in 10. And that is going to be 4 pi, so the integral from 0 to 4, plus the integral from 4 to 10. So the integral from 4 to 8 is a triangle. 1/2 base, 1, 2, 3, 4. Height is 6. So that's this triangle here. And then I have to add the trapezoid. The trapezoid has a width of 2. And the height is 6 and 4. Okay. All right. And then I add these up and I get 4 pi plus 12 plus 10. So that is 22 plus 4 pi is what capital F of 10 is. All right. And then F of 15. Yeah, room here. Over here. Capital F of 15 is equal to 4 pi plus 12. So that was this triangle here, had a area of 12, plus, and I'm just going to go ahead and say 1/2 base times height. So my height is 6 and my base is 7. So that's 4 pi plus 12 plus 21. So that's 4 pi plus 33. All right. So if you were just given, uh-oh, did I do something wrong? Sorry, I just want to double check my answers. I have 4 pi. No, I didn't do anything wrong. Okay. Check yourself to see if there's something wrong with my answer of 4 pi plus 22. But I think it's fine. It's 1/2 base of 4, height of 6, and then, oh, is this not exactly 4? This is not exactly 4. Okay, so I did have an issue here. I'm not even going to edit this video. I'm just going to go back and fix my issue now. Okay, so this line is at the point, let's see, 6, 7, 8, comma 6. And then this is the point 15, comma 0. So if I write the equation of, I'll go ahead and switch colors so you know what I'm talking about. The equation of that line is y is equal to, the slope would be down 6 over 7. That's y. And then it'd be x minus 15 plus 0. So then if I plug in x is equal to 8, nope, not 8, 10. I'm trying to find the height at 10. I get y is equal to negative 6/7 times negative 5. So I get y equals 30 over 7. Okay, that's why this is wrong. So this is actually not 12. I'm sorry, that is 12. Sorry. This part's the wrong part. That trapezoid is not 10. So let me go back and fix that. So that is a width of, let me draw that trapezoid back in, a width of 2 still. My first height is still 6, but my second height is actually 30 over 7. So that is 6 times 7 is 42 plus 30. 42 plus 30 is 72 over 7. So that is whatever. You don't have to simplify anymore. It's this. Ugh, tricky one. I got tricked. All right, and then lastly, find the intervals on 0 to 15 where f double prime is greater than 0. So f double prime is the slope of f prime. So the slope of f prime, which is f of x, lowercase f of x. So again, I'm looking at the derivative right now. This graph is the derivative graph. So when is the slope of this graph greater than 0? And that is from 0 to 8. And that's it. So D is from, sorry, not 0 to 8, 4 to 8. From 0 to 4, your slope is negative. From 4 to 8, your slope is positive. Right? So this was a very tricky problem, so I wouldn't be surprised if you got some of these answers wrong. That's okay. I did too. I had to fix my mistake. But make sure you study these types of problems because you will see them again, and they very often show up on the AP exam. Almost every year, there's something very similar to this.